At exactly 5:45 in the morning, while most of Russia was still asleep, 14 Ukrainian drones silently rose into the sky. They carried no markings, made almost no sound, and were armed with warheads weighing the equivalent of 40 kilograms of TNT each. Their target was not a frontline trench or a command post. It was a cargo ship anchored deep inside the Russian homeland in waters long considered untouchable, the Caspian Sea. No one in Moscow or Astrakhan had any idea what was coming. For decades, Russia saw the Caspian as a safe zone, far from the chaos of war. That belief died on August 14th. Ukraine had just rewritten the map of the conflict, reaching over 800 kilometers beyond its borders to strike a target that Russia thought was out of reach. It was not just an attack, it was a message. The vessel known as Port Olia 4 was not a warship, it was a 110 meters cargo ship, flying the Russian flag anchored carefully in the narrow Volga-Don Canal. But its appearance was deceiving. Below deck, hidden from plain sight, were nearly 5,000 tons of military cargo. These were not ordinary supplies. They were the lifeblood of Russia's drone campaign. The ship carried critical components for assembling Iran-supplied Shahed 136 and Shahed 238 drones, avionics modules, electrical power units, navigation chips, gyroscope sensors, and prepackaged drone bodies. Alongside those crates were pallets of 122mm artillery shells, the same type used by Russian multiple-launch rocket systems like the BM-21 Grad. Each drone Ukraine destroyed that morning could have been used to hit civilian targets across Ukraine. The cargo on board Port Olia 4 represented hundreds of potential strikes, thousands of lives in danger, and weeks of planned attacks. This was not just a ship, it was a floating arsenal. For weeks, Ukrainian intelligence had tracked this ship. Its location was no secret, but its cargo was. What changed the game was Ukraine's access to commercial Japanese SAR satellites. Unlike optical satellites that require clear skies, these synthetic aperture radar systems could see through clouds, darkness, and even camouflage. They detected the shape of the hull, the way it rocked with the current, and the pattern of its anchors. Each pass revealed more details until analysts were sure this was the ship, but radar was only one layer. The second layer came from signal intelligence. Ukrainian intercept teams picked up near silence from the ship's communication systems. No radio chatter, no ICE updates, no radar sweeps. That silence was the giveaway. It meant the ship was trying to hide, and when a boat tries to hide, it is usually hiding something. This dual-layer detection provided Ukrainian planners with a precise window, a 4 to 6 hour period during which the ship would be vulnerable, its crew unaware and unprepared. With that intel, Ukraine chose its weapon, the UJ-26R long-range drone. The UJ-26R is not an experimental weapon, it is a proven drone with a body made of lightweight composite materials and a radar signature small enough to evade most conventional tracking systems. It flies at speeds between 150 and 180 kilometers per hour, and can travel up to 1,200 kilometers in a single mission. Its guidance system uses a hybrid of GNSS and inertial navigation, backed by an electro-optical terminal phase to correct course in the final seconds before impact. 12 of these drones were loaded with explosives and programmed for attack. 2 additional drones were assigned as relay units, helping maintain secure communication across the long flight. Together, they formed a silent armada, flying low to avoid radar and high enough when needed to relay commands. Their job was to strike without warning, and without missing a target. For Russia, the idea that a drone could reach from Ukraine to the Caspian Sea was once unthinkable. The airspace seemed safe, protected by geography and distance. However, Ukraine did not send just one drone, it sent a coordinated wave with each vehicle, having a specific mission, direction, and target point. This strike did not happen randomly, it came after weeks of watching, planning, and adapting. It was a demonstration of patience, precision, and long-range capability. Ukraine did not just hit a ship, it shattered the illusion that geography could protect Russia from the consequences of its own aggression. What follows next is the story of how those drones reached their target, how they struck in perfect sequence, and how the Port Olia 4 met its end beneath the waters of the Caspian. That story begins with a battle plan crafted in silence and executed in 13 minutes of fury. Long before the first drone reached the Caspian, the mission was already taking shape in silence. Ukraine's eyes were watching from space and its ears were listening across the airwaves. The Operation against Port Olia 4 did not begin with a button press, it started with intelligence. For several days leading up to the strike, a set of commercial satellites owned by Japanese firms played a silent but decisive role. These were not traditional optical satellites that depend on clear skies. They were synthetic aperture radar platforms, or S, capable of seeing through cloud cover, darkness, and even smoke. What they detected was not just a ship, but the behavior of a boat trying to avoid detection. Analysts studied the outlines of its hull, the subtle pattern of how it drifted in anchor, and even how long it remained stationary during tidal shifts. Night after night, the data painted a clearer picture. This was no ordinary vessel. The satellites revealed more than just a location. They captured movement, or more precisely, the lack of it. Port Olia remained in the same stretch of the Volga-Don Canal for days, anchored carefully in an inland choke point where civilian radar coverage was thin and military attention was minimal, but that alone did not confirm the target. Ukraine needed a second layer of insight. Signal intelligence, or SIG-N, provided it. From forward listening stations and mobile intercept platforms, Ukrainian operators tracked the electromagnetic silence coming from the vessel. No radio traffic, no automatic identification system pings, no active radar. The ship was hiding in plain sight. To trained ears, that silence was louder than any signal. A vessel of that size, with no communications for 6 hours at a time, was either asleep or preparing for something it did not want observed. Together, the S and SIG-INT feeds enabled Ukrainian planners to identify what they referred to as a strike window, a quiet period of 4 to 6 hours each morning where the ship entered near complete emission silence and made no visible movements. This was the moment of vulnerability, a time when no one would expect a drone and no one would see it coming. With the window confirmed, the mission profile was drawn. Ukraine needed a drone that could travel across vast distances, fly low enough to evade radar, and carry a warhead strong enough to penetrate steel. That drone was the UJ-26R. The UJ-26R was not built for close-range firefights. It was made for reach and precision. Constructed with composite materials, its body reflected only a fraction of radar waves, making it appear smaller than a bird on some screens. Its cruising speed hovered between 150 and 180 kilometers per hour, providing an ideal balance between stability and stealth. It did not race toward its target, it glided patient and quiet. The guidance system inside the UJ-26R was among the most advanced in Ukraine's drone fleet, a combination of GNSS and inertia. Navigation allowed the drone to maintain course even when satellite signals were jammed or disrupted. In the final stage of flight, its optical sensors are activated. These electro-optical units scanned for visual confirmation, comparing real-time images to stored maps for verification. This was not just guidance, it was targeting. Each drone was fitted with a 40-kilogram warhead. But not all warheads were the same. Some were designed to create blast damage, shredding exposed decks and ventilation shafts. Others were semi-penetrating, designed to rupture fuel tanks and water lines. Still others carried delayed fuses, timed to explode inside cargo holds or engine compartments. The loadout was not random. It was chosen to underscore, not obliterate. The goal was to sink the ship without igniting its volatile cargo. In total, 14 drones were prepared, 12 for attack, 2 as communication relays. The relay drones flew higher, maintaining a secure data link back to command centers and allowing real-time adjustments. The attack drones flew low, skimming the surface of the Black Sea, then hugged the terrain and avoided coastal radar systems as they passed through southern Russia. Their route was not linear. It was curved, evasive, and built for one goal: to remain undetected. The drones were launched in sequence, but programmed for coordination. Each had a designated strike point. Some would hit the bow, others are stern. A group would aim for the midsection to destabilize the ship. The pair of relay drones orbited further back, watching and transmitting their observations. Every movement was calculated and every moment rehearsed. The selection of the UJ-26R over other drone platforms was deliberate. Ukraine needed a system that could fly great distances, think independently, and adapt in flight. Unlike simpler loitering munitions, these drones could receive mid-flight updates, adjust paths, and even abort if conditions changed. Their flexibility was as crucial as their range. The formation itself was a display of modern battlefield choreography. In the past, this kind of strike would have required human-crewed aircraft, risking pilot lives and diplomatic escalation. Now, a squadron of silent machines could cross multiple borders, evade detection, and arrive precisely on time. That precision, both in time and location, would make all the difference. The plan was set. The timing was precise. The weapons were ready. What came next would be the execution phase, where technology met intention and each drone moved into its final path toward Port Olia 4. The plan to take down Port Olia 4 was not designed for brute force. It was built on precision, timing, and an intimate understanding of how a ship breathes, moves, and dies. Ukrainian engineers and military planners had studied every known layout of similar cargo vessels. They mapped out vulnerabilities not just in the physical structure, but in how those systems interacted. The goal was simple: turn off the ship beyond recovery without triggering a catastrophic explosion. To achieve that, the drones were split into 4 strike groups. The first team approached from the stern. Their mission was to destroy the ship's engine room and disrupt its propulsion systems. One drone targeted the ventilation shaft to create internal fires. Another aimed directly at the propeller housing, while a third went for the auxiliary fuel pumps. A hit to this zone would cut power, damage generators, and ensure the ship could no longer move or self-stabilize. The second team moved in from the bow. Their targets were the bridge, the electrical control systems, and the primary radar units. These drones flew a more direct route, intending to arrive just moments after the first wave of the attack. If successful, they would plunge the control room into darkness, rendering the crew blind, deaf, and unable to coordinate a response. The third group focused on the ship's midsection. These drones were programmed to strike the waterline and the cargo hatch connections. A well-placed detonation in this area would allow seawater to flood into the lower compartments, destabilizing the cargo balance. One drone was set to pierce the outer hole near the port side. Another was meant to rupture internal support beams that held the deck together. By opening these points, the ship would begin to tilt, making rescue and damage control almost impossible. The final group consisted of 2 specialized drones flying slightly behind the rest. Their mission was to disrupt any incoming assistance. They carried specialized warheads designed to scatter shrapnel and create danger zones for tugboats or patrol crafts that might try to intervene. These drones acted as a shield, buying precious seconds for the main attack to complete its work. Each group had its own flight path, altitude profile, and timing offset. Together, they created a deadly choreography. The sequence was not simultaneous but staggered. Each impact opened a new weakness. Each delay forced a new panic. The result was designed to cascade. At exactly 10:28 local time, the first drone slammed into the stern. It hit with devastating accuracy, blasting open the engine ventilation cover and igniting electrical fires in the cable runs. Flames quickly spread along the lower deck. Within seconds, the second drone buried itself near the starboard propeller shaft, damaging the gear systems and sending shudders through the entire hull. At 10:30, another wave arrived. 2 drones struck the midsection. One detonated against a cargo hatch, its warhead collapsing the support frame and sending debris into the compartments below. The other punched through the lower hull, near the waterline, opening a gash that allowed seawater to rush in. Build pumps activated, but the power flickered as the electrical system struggled to stay online. By 10:31, a direct hit on the bridge caused chaos. The main control panel exploded into sparks, lighting up the control room in a brief blinding flash. Screens went dark, communications cut out. The captain gave the emergency command to switch to backup power, but it was already too late. The system had overloaded. Battery backups engaged for a few moments before failing. The sequence continued. At 10:33 and 10:34, 2 more drones hit the starboard side. One struck just below the water line, causing rapid flooding in the engine compartment. The other hit an upper ventilation duct, spreading smoke and fire into the crew's living quarters. At this point, the vessel began to list, the tilt growing with each passing minute. By 10:36, the ship was already leaning 7 degrees to starboard. Water had reached several critical compartments. Firefighting systems had failed. Pump stations were disabled. Crew members abandoned their posts and moved to lifeboats. The scene was one of confusion and desperation. Emergency beacons were activated, but response vessels were still minutes away. At 10:38, another drone found its mark. On the stern shaft tunnel, the earlier hits had already weakened. This area, the explosion ruptured a fuel line, causing oil to spill onto the lower deck. Fire met fuel, and the result was immediate. A blaze erupted that no remaining crew could contain. At 10:40, the final two attack drones completed their run. One struck the forward bow, sending debris high into the air. The second hit the opposite side of the midship, causing structural failure across multiple bulkheads. At the same time, the two escort drones released their countermeasures near the tugboat approach lanes. Explosions in the water created a wall of shock and debris, forcing rescue boats to retreat. By 10:41, the attack was over. The last drone had disappeared into the smoke. Port Olia 4 was mortally wounded. Its decks were burning, compartments flooding, and systems offline. Most of the crew had abandoned ship. The operation had taken just 13 minutes from the first impact to the last detonation. And yet, what unfolded in those 13 minutes would ripple far beyond the Caspian. The next chapter would reveal how Russia responded and what the sinking of Port Olia 4 meant for the broader war. By 10:50 a.m., Port Olia 4 was no longer a functioning vessel. The fires ignited by the drone strikes had spread across multiple decks. Water continued to pour through holes in the hull. Power was lost entirely. Engines were offline. Internal compartments had collapsed or were flooded. The crew had evacuated and there was no longer any effort to fight the damage. In every practical sense, the ship was dead, but the world would not know this immediately. In the hours that followed, Russian media offered no comment. Officials in Moscow said nothing. The Ministry of Defense remained silent. From a distance, only one thing spoke the truth. The sky, at precisely 14:32 local time, a commercial satellite passed over the Volga-Don Canal. Its imagery captured what no press release could deny. Port Olia 4 was gone. All that remained was a column of smoke rising slowly from the surface of the Caspian. Independent analysts from open source intelligence groups began examining the satellite images. They cross-referenced light pole placements, crane silhouettes, and shoreline structures to confirm the exact location of the wreck. Despite efforts to suppress information, the truth surfaced. The coordinates matched those of Port Olia 4's last known anchorage. The shape of the wreck, partially submerged and tilted, matched the ship's dimensions. The conclusion was unavoidable. Russia did attempt recovery. Tugboats were deployed. Salvage vessels arrived, but none of these efforts could hide the damage. The ship's superstructure had collapsed inward. The central cargo compartments were twisted and broken. Every indication suggested that the boat had been disabled beyond repair. Even if some parts were lifted from the water, the vessel itself was lost. What Ukraine had destroyed was not just a cargo ship, it was a floating warehouse of war. Based on open source reports and Ukrainian statements, the boat was believed to be carrying over 5,000 tons of drone-related equipment. Among them were hundreds of pre-manufactured airframes and specialized components for Shahed 136 and Shahed 238 drones. These included electrical units, flight control systems, gyroscopes, and power cells. Each Shahed drone carries approximately 40 kilograms of high explosive in its warhead. If even half the shipment was meant for active use, the potential impact was staggering. Ukraine had effectively removed over 12 metric tons of explosive warheads from the Russian inventory. That alone was a tactical success, but the broader impact was more severe. By hitting Port Olia 4, Ukraine disrupted an entire chain of supply that extended from Iran to Russian drone assembly facilities. The production of Shahed drones depends not only on design or workforce, but also on precision components that cannot be easily substituted. The destruction of this shipment meant that several production lines would pause or slow down, maintenance schedules would be missed, stockpiles would run low. Russian drone strikes, especially those launched at night against Ukrainian cities, began to taper off within days of the incident. In military terms, this was a well-placed strike, but in strategic terms, it marked a shift in how the war was being fought. For years, the Caspian had existed outside the boundaries of conventional warfare. It was seen as a Logistical safe zone, a rear area lake protected by geography and distance. Russia had treated it as untouchable. Ukraine changed that. The immediate consequences rippled through the shipping industry. Insurance premiums for vessels traveling to Russian Caspian ports surged. Several operators suspended deliveries. Others began sailing without broadcasting their positions on ice, making tracking more difficult and increasing the risk of miscalculating their location. Convoy formations became more common, which slowed delivery times and increased logistical costs. Everything took longer. Everything costs more. Russia attempted to reroute some cargo through land-based supply corridors, but these were already under pressure from other demands and far more vulnerable to Ukrainian strikes or sabotage. Bridges and rails can be bombed. Trains can be intercepted. What had once been a smooth channel between Iran and Russia was now fractured. The symbolic means